Hello everybody, welcome to NEET Physics by Arun video channel. In today's video, we are going to solve a question in motion of system of particles and the rigid bodies. Motion of system of particles and the rigid bodies. What is the question, sir? Let us look into the question. A rigid body rotates with an angular momentum L, capital L. If its kinetic energy is halved, becomes 1 by 2, halved, the angular momentum becomes, you are given 4 options, L, L by 2, 2L and L by root 2, square root of 2. This question has been asked in 2 examinations. In 1998, it has been asked in AFMC, Armed Force Medical Colleges examinations. And in 2015, it has been asked in AIPMT, All India Pre-Medical Test. Okay, so such an important question it is. Okay, so how to solve this problem? For a rotating rigid body, angular momentum L is equal to I omega. L is the angular momentum. What is I? Moment of inertia, and omega angular velocity. And also we know that kinetic energy of rotation. So kinetic energy of the body, shortly called as Ke, is equal to 1 by 2 I omega square. For a linear motion, half m square. Here it is half I omega square. Is it not? So I is the moment of inertia, omega is the velocity. Now let us analyze the 2 cases. Case 1, case 2. Case 1, angular momentum is equal to L1, which is equal to L because it has been given as L. Okay, is equal to I omega 1. L is equal to I omega. So here the moment of inertia of the body will not change, but when the kinetic energy is called, its angular velocity will change. And how it will change, sir? Let us see it. Okay, so L is equal to I omega 1, and kinetic energy Ke is equal to E1 is equal to half I omega 1 square. Here it is half I omega square. In the case, first case, it is half I omega 1 square. Let it be equation. For case 2, kinetic energy, angular momentum is L2. Actually, the value of angular momentum is we are going to find, and this is the question. So L2 is equal to I omega 2, and Ke is equal to half I omega 2 square. Is it not? So, let it be E2. Okay, E2. Okay. So case 1, we have equation 1. E1 is equal to half I omega 1 square. In case 2, E2 is equal to half I omega 2 square. Okay, that's it. So it is given that E2 is equal to E1 by 2. What does it mean, sir? When the kinetic energy is halved, what is the angular momentum? This is what which has been asked again, is it not? So E2 is equal to E1 by 2. So you bring the 2 to the other side, you can write 2E2 is equal to E1. 2E2 is equal to, so 2 into, what is E2? Half I omega 2 square. This 2 and 2 will get cancelled. That is equal to I omega 2 square. So this I omega 2 square, 2E2 is equal to E1. Okay. So this E1 is equal to I1. E1 is equal to I omega 2 square. Let it be equation 2. Also in the previous slide, we have seen that E1 is equal to 1 by 2 as half I omega 1 square. For E1, half I omega 1 square. So in equation 2 and equation 1, LHS are equal. So RHS must be equal. So half I omega 1 square is equal to I omega 2 square. So I in LHS and I in RHS get cancelled. So omega 2 square, you put this omega 1 square here. So you will get omega 2 square by omega 1 square is equal to 1 by 2. Okay? Omega 2 square by omega 1 square is equal to 1 by 2. So omega 2 by omega 2, taking square root on both sides, you will get omega 2 by omega 1 is equal to 1 by root 2. So also you can write omega 2 is equal to omega 1 divided by This omega 1, when goes to the other side, will be in the numerator. So omega 2 is equal to omega 1 divided by root 2. Now we have found the value of omega 2, but our aim is to find the value of L2. What is L2? I omega 2. I, instead of omega 2, you can substitute the value omega 1 by root 2. What is I omega 1? L1, which is also equal to capital L. This has been given in the question. L1 is equal to L. So L1 by square root 2, which is equal to L by square root 2, square root of 2. So when the kinetic energy Ke is halved, பாதியாகும்போது becomes 1 by 2, the angular momentum becomes L by root 2. So this is L by root 2 is option 4. This L by root 2 is option 4. No. So the option 4 is the right answer for this question. So we will see one more MCQ in this chapter, motion of system of particles and rigid bodies, in our next video. Till then, thank you one and all.